Hello, everybody. Welcome to a new School of Data Skillshare. We are here with Camila Salazar from Costa Rica, who is a new 2015 School of Data Fellow. School of Data is a community and a project about helping journalists, civil society, citizens getting a better skills in data literacy, which means analyzing data, finding data, and being able to use data for transparency, democracy, and generally a better society. Today, we are going to talk about regression analysis in data journalism especially, which is about basically upping your skill level in statistics applied to data journalism. In this 30 to 40-minute presentation, Camila Salazar will first introduce herself and then go on with her Skillshare. Camila?
Hello, Cedric and everyone, the School of Data community. Well, as Cedric said, I'm a School of Data Fellow for 2015, and I've been working with this great people from all around the world that's involved with School of Data, and I'm a data journalist, so I've been working as a data journalist and also doing trainings in data journalism and data analysis, so I really hope that you enjoy this Skillshare, and if you have any questions, just ask them on Twitter, or we'll be glad to ask them. So I hope you enjoy this Skillshare. So to start over here, the idea, as I said earlier, is that this Skillshare is about regression analysis for data journalism, and it's an introduction. So the idea of this is that when you start working as a data journalist, you start with descriptive statistics. So the idea is to level your skills a little bit and see what other things you can do with statistics. So let me just share my screen over here so that you can see the presentation. There you go. Okay, so to start a bit, I'm going to talk about the outline of this Skillshare. First, the idea is to talk about the target audience for whom it could be useful. And then I call the second part a step beyond descriptive statistics, because as I said, when you start doing data journalism, you mostly start with descriptive statistics, and this is like a step beyond that. And then I'm going to explain you the basics of regression analysis. And then what is the linear regression model? That is like the first model you use when you start working with regression analysis. And then an example for you to better understand what I'm talking about, that it's called the effect of education on wages. And then I'm gonna give you a quick glimpse of other types of regression analysis and other models that could be useful in data journalism, just so you know that they exist and how could you apply them. And then at last, some examples of how some newsrooms have used this type of analysis to create great journalistic stories. So I hope that this would be useful for you. So first, the target audience. I thought this Skillshare could be good first for data journalists. And if you're a data journalist, you must be a bit savvy with data and you know how to do some calculations and you know basic statistics. So I think this could be useful for you. It could be a new tool that you could use in your newsrooms. Also for School of Data Fellows and for all the School of Data community that might be interested if they already don't know about this. And also people with basic knowledge of statistics. I'm going to talk here about some statistical concepts that it would be easier to understand if you know some basics about statistics, but if not, I'll try to explain them so if you don't know already. And then also journalism students that might have taken a course in statistics and that are interested in learning what can you do with numbers if you work as a journalist. So to start first, I call this a step beyond descriptive statistics, because basically when you start doing data journalism, you have a spreadsheet and you have your data and you learn how to make basic calculations with the data. But the idea of this is to go a bit further. So to start is, I put an example that when you're in a newsroom and you want to create a new story, it basically, a story comes because you're interested in writing about it, or because it's a topic that it's generating a big debate in your country. So imagine that there's a big debate in your country about the importance of education, and the Ministry of Education is trying to cut off some spending, and some people are really worried. So your editor asks you to make a story about the importance of education and to generate content about the topic that everybody's talking about. So if you're a data journalist, the first thing you do is that you go and find some data about education in your country, and you start calculating the descriptive statistics, and you start digging in that database to find a story and to tell the story that you've been asked to write. And with descriptive statistics, you can imagine that you have a survey about households in your country, and you can find with that database, for example, how many people has a college degree, how many young kids have dropped out of high school, or calculate the unemployment according to the level of education. And then you have these nice charts and these nice tables about your topic. And then you go into the field, and you're interested in that statistic about that people are dropping out of high school. And you interview these young kids, and they tell you, well, that they're not really motivated, that they don't want to go to college, they just want to quit high school. And you get really worried, and you really want to convince them that they could improve their future earnings if they go to college, that they could have a better future if they continue to their education. So you really can answer those questions with those descriptive statistics. So you want to go a step beyond. Like you want to calculate, like you want to make a model, or you want to tell a story in which you can tell these kids, well, if you study like 2 extra years, you'll have your future earnings will increase in this amount of money. So even if you can do this with descriptive statistics, you can do this with regression analysis. And that's the power of this kind of models and statistics, that you can create more interesting stories than the ones you do only with descriptives. So that's a way that you could think of doing regression analysis. How could this be useful? So to start, I want to tell you first what is regression analysis. And it's basically a statistical tool for the investigation of relationship between variables. Remember, we were trying to find a relationship between education and wages. So this is what regression analysis can do. And a way to see it, like a technical definition, is that it helps you explain how the value of a dependent variable, that I'm going to explain later what it is, changes when an independent variable when one or more independent variables are changed, is varied, holding all other variables fixed. So you have one dependent variable and then some independent variables. And a way to see this is, for example, you know that if you want to be a healthy person, your health depends on how much well you eat, how much exercise you do, how well do you sleep. So this is a way of seeing. This would be the dependent variable, your health, that depends on these other things, that depends on how many vegetables you eat and how much exercise and how much sleep. And this would be the independent variables that try to explain, in this case, the dependent variable. So you'll have these 2 kinds of variables, and you incorporate this in the regression analysis. So the first method that you see when you use regression analysis is basically the linear regression. That it's a method for modeling the linear relationship between dependent and independent or explanatory variables. And the point here is that it's a linear relationship. It's like a mathematical concept, but it's like the first model you see or you use when you try to work with regression analysis. So the model goes a bit like this. This is like the basic equation. And as I said, here you have the y, that it would be your dependent variable. You have here the independent variables. Imagine this is your health, or this is wage. And this would be your independent variable, that it could be education. And then you have these coefficients over here that I'm going to explain what are there? And then you have this error term. And this error term basically tells you or captures all the variability of y that you can capture in x, or like the random things that you can explain with all your explanatory variables. And a way of seeing it is that if you have this over here, that you know that health depends on vegetables, exercise, sleep, maybe some genetic disorders in your family. But imagine that you go out you went out yesterday and it was raining and you got your flu. So this was a random event that you can really capture in those variables. So that would be basically captured in this error term. And every time you run a regression analysis, you have to add this term, because it's really hard to explain one phenomena, to find all the variables that explain one phenomena. There's always a random thing that has influence on this dependent variable. So that's why you use an error term. And then what we're really interested in finding in a regression is the value of this coefficient over here, because it basically captures the exact effect that x, or that the independent variables have on the dependent variable, holding all other factors fixed. So we're really interested in finding what the value of this coefficient is over here, and that will be like the big point of the linear regression model. So an easier way for you to understand this is maybe if we see it graphically. So as I said, we were interested in convincing these kids to stay in high school. So we wanted to explain the effect that education had on wages. So here we could write this equation like this one right here, where you have your wage, that it would be your dependent variable. Then you'll have your coefficients. You have your independent variables. This would be education. This would be experience. And this would be the random term. And a way of seeing it is that you have wage over here, and then you have education. And this intersection over here would be the variation in wage that has to do with education. And then this would be experience, and this intersection would tell you the variation in wage that has to do with experience. And as you can see, we could continue to add some other variables that might explain wage, for example, gender or occupation field, or I don't know, if you work in the public or the private sector. And all of this would create like intersections over here that would explain some of the variability of wage. And then before continuing and trying to explain to you how do you run a linear regression, it's really important that when you build an equation like this, you have to build it based on some theory and based on and have some assumptions about the hypothesis that you're trying to test. For instance, there are a lot of studies and there's a lot of economic theory that says that if you study more, there should be a positive relationship between education and wages. So you have some theory that supports that you build this equation. And this is really important because you want to prove relationships that make sense. So that's why you have to have some theory behind those assumptions. And you also have to make assumptions about, for example, I would expect in this equation that the more educated you are, the higher the wage. And the same goes for experience. If you have more experience, then your wage, there would be a positive relationship with wage. So that's why you have to build some theory. And another really important thing is that a linear regression model, to run it, there are some essential assumptions and statistical properties of the regression that you have to consider that I'm not going to go deep in this Skillshare, but these are some properties that you always have to test when you run a linear regression in order for your results to be valid. And there are like mathematical concepts and assumptions that you have to make. And even though I'm not going to go deep further into this over here, it's really important that you take this into account. And if you're going to run a regression model, then at the end of this Skillshare, I'm going to share you some links of books and courses that you can follow to check these assumptions and to know that they exist, because it's really, really important. I should have highlighted this in yellow. So an easy way to see these, I run this example, the effect of education on wages. So imagine that you have a database with this amount of observations. And then you have three variables that it's basically wage in dollars. It's measured in dollars. You have years of experience, and you also have years of education. And you want to estimate this equation over here. That was the one we had earlier. When you have your wage, you have education, and you have experience, and you want to run this regression. To run these models, we most of the time use statistical programs. You could run them in spreadsheets, but you have to add like some plugins to your Excel, depending if you're using Excel for Mac or for Windows. But I really encourage you, it's way easier to do it on statistical programs. And as I will show you over here, I run this with a program called Stata. Let me wait. I have it over here. There you go. Oh, wait. Oh. I have it here. I run this regression model with Stata, that it's a statistical program that you use for analyzing data. You could also use SPSS, or you could use R. And I'm not going to show you how to use Stata, but if you know, I just want to show you how easy it is to run a regression model in these programs. So for example, I want to run a regression about my dependent variable is wage, and then I have two independent variables. And you just write a quick command that is called regress, and you put wage, you put your education, and then you put your experience. You write here your independent variables, and then you run this, and you get this chart right here. I just want you to see that it's just a line of command, and then you have your results. So it's really, really quickly. Once you know how to use this, that it's not really hard, then you can run this, and it's the same as if you use other statistical programs. And maybe in another Skillshare, we can see how to use this program. But you get this table over here of results. So I'm gonna go back here, and then, as I said, you get this table. This is like the basic table that you get when you run a regression. And this could that at first you could see that it might look a bit overwhelming to see all these numbers and stuff, but the idea is to know what to look for in this table and how to interpret it. So that's the exercise we're going to do now. So here we have this table, and as I highlighted here, we're going to look at these things over here. So the first thing you do is you check for the coefficients. Remember that we were really interested in knowing these coefficients. This is what we're really trying to estimate in the regression. So the way you look at this is, here you have your dependent variable, and here are the independent variables. And this over here, this amount would be this one over here, this coefficient. So the way to interpret this is that, for example, this one is that an additional year of education increases your wage by $161, holding all other factors fixed. And then we have that this one over here, you can interpret this that an additional year of experience increases wage by $16, holding all other factors fixed. So basically, we interpret this as in the same unit as the dependent variable, that in this case is dollars. And you know that this increases your wage because you have a positive sign over here. And then we have this this one over here is the constant that I wouldn't really encourage you to look really deep into this. This doesn't make much sense, and you're not interested in finding this coefficient, but it basically means that if you have 0 years of schooling and 0 years of experience, then your wage would be $763 negative. So it doesn't make much sense. So what you really have to look for is these coefficients over here. So just a second, and then over here. So you have first the coefficients. And then, as I said, the second thing we want to look at is the p-value. And here's the p-value. And if you don't already know what the p-value is, we're going to make like a big parenthesis here and explain to you what the p-value is and why is it really important to see this thing, this column over here in your results. So basically, to explain the p-value with statistics, when you make statistic calculations, you can be 100% certain all the time because there's a chance that your results could occur by chance. So a relative simple way to interpret the p-value is to think of them as representing how likely a result could occur by chance. And when you do statistical calculations, you always have to build something called the null hypothesis. That it's basically a hypothesis which the researcher tries to disprove, reject, or nullify. So you're basically always trying to reject the null hypothesis. You never accept the null hypothesis. You just reject it or not reject it. So an idea to see this, in our example, we have the assumption that education has explanatory power on wages because if you study more, then you have a higher wage. But in this case, our null hypothesis, we'll have to formulate it like this, that education has no explanatory power over wages in order, because we really want to reject this hypothesis to prove that our calculations are right and that education have explanatory power on wages. And for example, we could have, imagine that we have a lot of data about the height of men and women. And we have the assumption that on average, men tend to be taller than women. So our null hypothesis in this case would be that men are not taller than women on average. And to test this null hypothesis, what we use is the p-value. And basically, what the p-value is the probability of being wrong when rejecting the null hypothesis. And you reject this null hypothesis when you have strong evidence, when the p-value is really, really small. So to put in an example is we had over here that a null hypothesis is that men are not taller than women on average. So imagine that we run the analysis and we find that indeed men on average are taller than women. And we have the p-value of this calculation that is over here. So what this means basically is that there's a 1% chance that men are not actually taller than women and that this result happened only because of random chance. So there's 1% probability that your calculations are because of random chance, so that this result is not statistic. It's not right. So that's what I say when the p-value is the probability of being wrong when rejecting the null hypothesis. Because if you reject this null hypothesis that men are not taller than women, then the probability of being wrong when rejecting this hypothesis would be this p-value over here, this 1%. And that's really important because, as I said, in statistics, you can be 100% certain. So you have to have there's a really, really small chance. And when you always try to look is that this chance of being wrong can be really, really small. So that's why you always want a small p-value to have strong evidence against your null hypothesis. And this basically means that your results are okay. So to go back to the example, we have the coefficients right here, and we have a p-value associated to each one of these coefficients. So if you look over here, this p-value is really, really small. So that's a good sign. And our null hypothesis here, where that education has no explanatory power and experience had no explanatory power. So since our p-value is really small, then we can reject this hypothesis and say that, well, this means that education and experience have explanatory power and weight, and that our coefficients are statistically significant. And that's what you're always trying to look when you find your results. So making a summary of all this, when you have this big table over here, you first check the sign of your coefficients. You see if the relationship is positive or negative. And then after you check this, you have to check the p-value. And you always want to look for low p-values for these results to be valid and to be sure that, in this case, there's strong evidence about your assumption that education has a positive effect on wages. So we have this over here. And then what I highlighted here is another thing that you check when you run a regression model that is called the R-squared. That basically, the R-squared indicates how well the explanatory variables explain the variability of the dependent variable. And in this case, 33% of the variability of wage is explained by the years of education. And what you're trying to find here is that, remember this chart, let me see, this chart over here. And you would say, if we had this circle right here, is that this and this is like 30% of the variability in wage is explained by these two variables. And when you run a regression, you want a high R-squared, but not really high. So you'd be confident if your model, if your R-squared is between like 60%. If you have like an R-squared of 90%, that's not a good sign. So because it's really hard, as I said, to find all the variables that explain your model. So you must check this sign. This is a good sign that your model is good. And in this case, since the R-squared is quite low, maybe this would suggest that we should add more variables like field of occupation or gender that would explain more of the phenomena that we're trying to explain. And also here on top, we have the number of observations that you really have to check them. A good number for observations, it would be a regression model with less than 50 observations. It's not really good because of properties of numbers. So you always want to run a regression model that has at least more than 50 observations. So remember, if you have questions, just ask them on Twitter. And then what I want to show you real quickly is some other types of regression analysis that you can run. As I said, the linear model is like the first model you see, but there are other types of regression analysis that you could use that depend on the model that you're trying, on the phenomena that you're trying to study, and also on the characteristics of your variables. So there's another type of regression model that's called the logistic regression. And you would use this model if you, for example, want to estimate the probability that a person with a college degree is employed. And the linear regression in this case wouldn't be very useful because basically your dependent variable is not like wage, that it's a continuous numeric variable. But in this case, it's a category. You're either employed or unemployed. So a way of seeing this is that basically what the logistic regression model does is it's a model where the dependent variable is categorical. It means it has two or more categories. In this case, we only have two categories, that is unemployed and employed. And it used to estimate the probability that you're either employed or unemployed based on one or more independent variables. So to see this in a chart, maybe it's easier for you. You'll have some explanatory variables like age, education, family income, occupation. And then you put all these explanatory variables in your logistic regression model, and then you get like two results, like the probability of being employed versus unemployed. And with this model, you can find results like, for example, the model can tell you or could tell you that a person with a college degree is 3 times more likely to be employed than a person with a high school degree. So this is what the sort of things that you could calculate with this model. So you basically use this, as I said, if you have a dependent variable y that is not like numerical or continuous, that is categorical. You can have here employed, unemployed, or maybe you can have this, I don't know, if you have a car or not, if you recycle or not, if you get a credit or not, stuff like that. So that's when you should use the logistic regression. And I'm not going to go deep into how to interpret this because it's a bit more hard than the linear regression type. But the idea is that you know that this exists. And if you want to go further, then you can have some courses, or we can have another Skillshare. But basically, the basics is that the coefficients cannot be interpreted as the rate of change in the dependent variable, as we saw with the linear regression. And what you basically do is that you check the signs of the coefficients. And if it's positive, then this would tell you, for example, if you find that education has a positive sign, the coefficient, then you would say that education increases the probability of being employed. And then you can calculate something called marginal effects for odds ratio, an odds ratio that would basically help you find this result, like to find how many times it is more or less likely to find a certain result. So this is basically the logistic, like a really quick introduction to what logistic regression is. But remember, if you have more questions, we can go into that later. So, and maybe after all this talk that I've done, maybe you're quite scared and you think, well, I really don't understand how I could use this in my newsroom. I don't see it very useful, or I don't see big newsrooms doing this. But what I really encourage you to do first, it's not super easy, but it's not super hard. So it just takes some time to learn it. And actually, there are great examples in newsrooms that have used regression models to create great journalistic stories. So I want to show you a couple examples I found. Here's one. It's basically the example that I've been developing, that this was a work done by a newspaper called El Financiero in Costa Rica. That was basically, and they won the Data Journalism Awards of 2015, my mistake over here. But it basically calculated how much education increases wages. So I'm gonna go over here to show you this. This is the app they built, and it's in Spanish, but it basically says, how can I increase my wage? So you basically start over here in this app. And then what you had to do over here is to give some information. Here is your gender. So for example, I'll put I'm a woman and I live in the city and I have like 25 years of age and I work 40 hours a week. And all of these are the independent variables that are trying to explain wage. So you have here gender, you have where do you live, you have age, how many hours do you work per week, what is your level of education, what is if you work for the private sector or the public sector, and if you work, for example, what's your field of occupation. So basically you add all these characteristics, all these dependent variables, and then you can check what is your average weight with those characteristics. And you also could see, like, for example, if I have this wage, what happens if I do a master's degree, and then you see that your wage increases. So this is a great example of, this is built on a linear regression model. As you can see, we have our independent variables and we have our dependent variables. And what they did here is that they built an app that could be useful for people to check and to really see the effect that your education had on your wage. So this was a great work, and it was all built with linear regression models. And they even won a Data Journalism Prize with this work. And you have the link over here if you want to check into this. This is a great example of data journalism using regression analysis. And then I have this one over here that is work done by ProPublica, that I have it over here basically, that it was a work done, they collected all the data about the presidential pardons that they gave in the United States, and they start analyzing the data, and the conclusion they made is that these presidential pardons heavily favor whites. And how did they do this? If you can see here, their lead, it says that white criminals seeking presidential pardons over the past decade have been nearly 4 times as likely to succeed as minorities, a ProPublica examination has found. So the way they did this, they published also the methodology of this. And what they did was basically to create a logistic regression model in order to have or to calculate this result. And if you check the methodology over here, you see that they calculated all the descriptive statistics, of the data. And then they created a regression model over here. This is a logistic, this is the results. And if you see this over here, this is non-Hispanic white, and then this coefficient that it's 4 is basically this one over here, the reporting. They're saying that white criminals have been 4 times as likely to succeed as minorities over here. So the idea here is that with descriptive statistics, they couldn't have get this result. They couldn't have gotten this result. So they used a logistic regression. And what's also really good about this story, it's like a big story. It has like 2 parts. I'll share the link over here. But the good part about this story is that they didn't also publish the story, but they published the methodology. So this is really important, and you have to be really transparent with your results. And in this case, if another person wanted to run the model, then you could see which variables they use and etc. So that's really, really good. So as you can see, there are some great examples in big newsrooms that are using these models, and I really, really encourage you to try them and to go further into them. And to end this Skillshare, I want to share with you some advice. And basically, the first one is that statistical analysis can be complex. And if you're not sure, find advice with an expert. When you run models, you can find a lot of problems, and you have to test your hypothesis and your assumptions over and over again. And this can get quite complex. So if you're not sure, it's better to find advice with an expert than to publish something that doesn't make much sense. So please do this. And it's funny because sometimes economists or statisticians that are working on this, if you as a journalist ask for their help, they might be interested in helping you. For example, this work that I show you over here was made by the data journalist and an economist. So they work together to build the model. So it's a good example of how can you build an interdisciplinary team to make this kind of works. And also, as I said, as I pointed out, be really transparent with your methodology. You're doing scientific methods to work with your data. So really be transparent with your methodology. If you build your story, have part of your story when you explain what variables you use, what calculations, how do you build a model, how do you test it, etc. So that's really important because you want to create confidence with your audience, and also to be transparent with the public. And also, you have to study a lot. As I said, this might look easy. It's not super hard, but you really have to study. And if you are interested in learning more about regression analysis, I really encourage you to go and study more and find some econometric books that explain really well what regression analysis do and all the models that you could build. And also, for example, Coursera, that it's a page for free courses. They have a lot of courses about regression analysis, and you can check in this link over here. There are a lot of classes that you can look for if you want to learn more about this. And here are some of the reference I use, some econometric books I use for the calculations, this survey. And thank you very much. I hope you enjoy this. I hope you learned something new. And I hope that you're not afraid to use statistics as a data journalist and to try these models. And if you have some questions, here's my Twitter. And you can also find us on schoolofdata.org. And thank you.
Camila, can you hear me?
Yeah, I can hear you, Cedric.
So we have a question about the way you work with regression analysis.
Mm-hmm.
If you have this data set about wages and education level, etc., we need only one regression analysis to have the answer that you, or will you need to enter more than 2 variables? How do you?
Sorry, Cedric, can you repeat, because the audio was like a bit cut off? So
can you hear me now?
Yeah, I can hear you.
So I'm saying, using the dataset example that you used before,
mm-hmm.
How would you explore this dataset? will one regression analysis be enough? Or will, with multiple variables, for example, if you need to analyze more variables, will you add like 3-4 variables in the equation? Or will you rather do several regression analyses, analyzing the link between 2 variables, then 2 others, then 2 others, etc.? How do you work it out?
Yeah, basically what you do with regression analysis, in this example, I only use 2 variables to make it simple. But if you're working on this, what you would do is that, well, this I did this like a really small data set for this example. But what you basically would do is that, for example, you have a list of all your variables. So in this case, you would use age, or you would use education, you would use experience, gender, etc. And you have all these variables. And what you would do is that you test them, and you test different specifications with that model. For example, in one model, you only use age and experience, and then age squared age and education. And then you test another model with different variables, or adding or subtracting one variable. And what you basically do is that you test all these different models, and there are criteria to pick between models, which is the best model. There are like statistical tests that you could do to see which model works better for your data. So that's what you basically do. Like, as I said, you can run this regression over here, but this is only one step. If you want to really estimate this model, you should run several tests and run different specifications of the model, so that you can be sure that your model is the best that you could write.
Thank you very much. I think that was the only question that we had.
Okay.
We have a remark from someone on Twitter saying that statistical significance is like being pregnant. Either it or it isn't. No, somewhat significant.
Yeah. Basically.
Okay, thank you very much, Camila. Everybody can still ask questions on Twitter by tweeting to School of Data or tweeting to Camila directly. And thank you for everybody who followed along. The video of the Skillshare will be available on YouTube shortly. Thank you, Camila. Bye.
Thank you, everyone. Bye.